So welcome to this new lesson on HVAC system in smart homes. This lesson is part of the unit on smart homes of the Secove project. But before starting talking about HVAC systems in smart homes, let's first understand what actually is HVAC systems. HVAC stands for heating, ventilation, and air conditioning. Basically, it's the systems that can control temperature, humidity, airflow, and air quality in order to maintain comfort and health in our homes, and which is responsible for regulating indoor climate. The biggest problem of these systems are that they account for approximately 40% of building total energy consumption, requiring efficiency optimization. The main focus of the system is to adapt to condition. Substantially, the system adjusts to external weather, occupancy level, and space-specific needs to guarantee comfort. So, HVAC systems are composed of different parts. First, the first component is the boiler, which is responsible for heating air and water for climate control. Inside the boiler, there is the heat transfer process. Basically, boilers combust fuel to heat water or steam, which is circulated for heating. We have different types of boilers. We have conventional open condensing boilers, and boilers can have the condensing unit, which can actually save energy, improving the efficiency until 90% by utilizing exhaust heat. We have two different kinds of heating system. One is fire tube and the other one is water tube. Fire tube basically pass combustion gases through tubes, while water tubes, boilers, circulate water through heated tubes. So, for what concerns the air conditioning, on the other side, chillers are the ones that are responsible of cooling the air. Inside chillers, we have the refrigeration cycles, in which chillers actually cool air by compressing and evaporating refrigerants, removing it from the building. We can have different types of chillers: air-cooled, water-cooled, and evaporative chillers. Finally, compressors, which are an important part of chillers, can work in different manners. The final part of the HVAC system is the air handling and terminal units, which is responsible of managing airflow during heating and during cooling. The units basically regulate airflow, filter the air, and distribute heated and cooler air around the building. Thermal zoning and thermal units control air volume and temperature based on specific thermal load requirements. We can have variable air volume systems which adjust airflow dynamically, while on the other side, another possibility is to adopt constant air volume systems, which maintain a steady flow. Regards efficiency and regulation standards, we have different metrics. For what concerns the efficiency metrics, we have different options. The most famous is the COP, which measure HVAC performance under different conditions. For what concerns the standards and regulation, the EU Energy Efficiency Directive and HRI set efficiency standards to improve HVAC sustainability. Finally, associations like LEEDs encourage high efficiency system adoption through financial incentives. But considering how much energy HVAC system actually consume, let's look at some efficiency strategies. First strategies is to actually reduce HVAC loads. So the adoption of efficient lighting and electronic switching from incandescent to LED lighting actually reduces heat generation and lowers HVAC cooling demands. Enhancing insulation and air sealing of the building at the same time can reduce energy losses, improving overall efficiency. The adoption of economizer can actually provide free cooling by using outdoor air when conditions allows, reducing HVAC system workload. Another possible strategy is to enhance the efficiency of our HVAC system is the correct HVAC equipment sizing. First of all, it's important to avoid oversizing or undersizing. This is because oversized system waste energy while undersized unit can struggle to maintain comfort and ventilation. On the other hand, it's important to size the system on the specific of the building. As SRI guidelines consider envelope load, internal load, and ventilation needs for proper sizing. So it's important to follow guidelines. Finally, system-wide optimization, adopting high-efficiency chillers don't actually guarantee efficiency, but it's important to have the whole system together that is efficient. Another strategy can be to take care of the sequence of operation because all parts of the system actually interact. So first of all, the thermostat detects temperature changes and signals the system to activate heating or cooling. The component interaction is fundamental. Blowers, compressors, condenser, and evaporators work in sequence to regulate indoor climate. So consider this cycle is important to make it as much efficiency as possible. Proper sequences optimize energy use and extend system lifespan by reducing unnecessary cycling. Another important part for keeping our system as much efficient as possible is to have a constant maintenance. It's important to have a regular filter replacement, cold cleaning and lubrication to improve system performance. It's important the placement of the equipment in order to make the maintenance as easier as possible and reduce the service cost. In order to extend the equipment lifespan, preventive maintenance minimize failure, reducing expensive repair and energy waste. Another important strategies can be the displacement ventilation. So the efficient airflow management can actually improve the efficiency of our system. Fresh air enters at floor level, displacing warm waste air to the ceiling for exhaust. In this way, we have an improved air quality, separating occupied and unoccupied air layer. This system can also improve energy savings by lowering cooling loads and reduce HVAC equipment size, lead to cost reduction. Finally, the most important strategies in order to improve the efficiency of HVAC system is the adoption of advanced controls and automation. Real-time monitoring actually can track temperature, humidity, and floor to ensure optimal condition. At the same time, direct digital control automates HVAC operation, optimizing energy use and response time. And finally, the integration with smart homes provide HVAC system to connect with IoT devices and building management software that actually enhance efficiency in our home. Thank you for listening.